So in this video, we are going to start looking at transformations of absolute value functions. So this video is going to focus specifically on the a value and how it alters that parent absolute value graph. So what you should be familiar with already is the parent graph for the absolute value function. Here we have our equation for that parent graph of y equals the absolute value of x. We then have our table of values with x having values from -2 to 2. And then the y values, we plug x in to find y. And then here's our table. And then remember, our domain of this graph is all real numbers, and our range is y is greater than or equal to 0. So this is something you should already be familiar with. Now, what we're going to look at today is we're going to look at what happens when we multiply this absolute value of x by a number. So here I have a value of a. Notice I have my multiplication symbol in there to remember that something smushed up right next to the absolute value is multiplication. But what we're going to do is we're going to experiment, and we're going to see what happens as I change this a value on my graph. So I have a couple of different ways I'm going to change this a value. The first thing I'm going to do is I'm going to change a to be something that is bigger than 1. So here we can see a is currently set at 1. Underneath here in red, the parent graph will always be on the screen, and the graph that we are changing the a value of will be over the top in blue. So notice here that I have a is equal to 1. If I start to change a, what I notice is that graph starts to get skinnier. Skinnier, 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 skinnier when compared to the parent graph. And that's because what's really happening here is this graph is having something called a vertical stretch done to it. So notice when a is 1, it's the same as the parent graph. But when I change a to be 2, we see that that graph kind of gets a little skinnier. It stretches a little bit. And essentially what's happening here is we're taking every value of the absolute value for x and we're multiplying it by 2. So think about it this way. If I took you and I took your height and I multiplied it by 2 but gave you the same weight, you would get skinnier because I would have to pull up your head and your shoulders and everything to make you that height of twice as tall. So this value of a can do something called stretch your graph up. So if I have 3, becomes 3 times as tall, or 4, it becomes 4 times as tall. That a value can have a really unique effect, and it can actually stretch your graph up by a factor of, we're seeing here, we saw 2, 3, 4, etc. That's the first thing that a can do. Now, this same type of thing happens when a is a negative number. So say I change a to a -1. You'll notice here that when I change a to a -1, it simply takes the a value and it flips it over the x-axis, or it reflects it. So those a values are mirrored if they're positive or negative. It just positive or negative tells you which side of the coordinate plane you're going to find that graph on. Notice if I change a to be a -2, again, it becomes a little bit skinnier. It stretches up by a factor of 2. Same with 3, same with 4. You can see it getting skinnier, 5, so on and so forth. And I can continue going to 6, to 7, to 8, to 9, to 10. So our a values, if they are bigger than 1 or more negative than -1, essentially what happens is we are stretching that graph up. So that's the first thing that you're going to see happen. We're going to summarize that right here. So our a value here, there we go. Our a value, so if it's something that is, so a is bigger than 1 or a is more negative or smaller than -1. So if we see that happening, what we're going to also notice is that we have something called a vertical stretch. So essentially the graph is stretching to be that many times taller. So for example, if a is equal to 2 or -2, the graph is 2 times as tall, and the graph will, in essence, become skinnier. So that's the first thing that you are going to see. The second thing that we already saw in action as well is when a is negative. You saw that a flips over the x-axis when it's negative. When a is negative, it is called a vertical flip. And this is essentially a reflection over the x-axis, and it puts it in quadrants 3 and 4. So that will happen when a is a negative value. Now the last thing we need to look at is what happens when a is trapped between 0 and 1 or 0 and negative 1. So essentially we're going to see that a is bigger than 0 but smaller than 1, or a is bigger than negative 1 but also smaller than 0. So it's trapped in one of these regions. And if we go back here and we look and say we change a to something like 0.5, what we notice happening here is this graph is becoming wider. And what's really happening is we're taking the height of that graph and then we're multiplying it by a half. And think about if I took your height and I multiplied it by a half but left you the same weight, you would in essence get wider because your weight would have to compress down. So if I took your height and I smushed you down, you would get wider as well. So what's happening here when say we have a is equal to 0.5 or a is equal to negative 0.5, when we have that value trapped between 0 and 1 or 0 and negative 1, what's happening is we have something that is called shrink. And the graph is shrinking to be a fraction of the parent graph's height. Essentially, if a equals 1/2 or negative 1/2, the graph is half its height and will become wider. So what we're going to do on this last slide here is we're going to look at each of these 4 graphs and make a prediction about what's going to happen to them compared to the parent graph. So here we have y is equal to 4 times the absolute value of x. So here I know that a is equal to 4. Because a is equal to 4, I know I have a vertical stretch, because it's bigger than 1, of a factor of 4. Essentially, it's going to become skinnier and taller. Then here, if I look at the second example, y equals negative 1/4. Here I see, or times the absolute value of x. Here I see an a value of negative 1/4. So the first thing I notice is that a is negative. So we're going to have a vertical flip because of that negative value. And then if I look at the 1/4 piece, the 1/4, whether it's positive or negative, positive 1/4 will be between 0 and 1. Negative 1/4 is between 0 and negative 1. So this is really a vertical shrink by a factor of 1/4. Essentially what it's doing is shrinking it to 1/4 of its height. Just like over here when we took 4 and we stretched it to 4 times its height. That's essentially what we're doing. So here we would expect it to get wider. Okay, 2 more. So y equals 2/3 times the absolute value of x. So a is equal to 2/3. I see that that value is trapped between 0 and 1. So I know this is a vertical shrink by a factor of 2/3. So what's going to happen is it's going to shrink to 2/3 height. And in essence, I then expect it to become wider. And then finally, this last example, we see y equals negative 6 times the absolute value of x. Here we have a is equal to negative 6. Because it's a negative value,